To establish fair market pricing without bias, traditional finance relies heavily on the power of the sealed bid auction. On a standard EVM, the Ethereum virtual machine, executing a true sealed bid auction is mathematically impossible. The bottleneck lies in imperative execution. To trade on a standard decentralized exchange, you must publicly broadcast your exact execution path, defining the tokens, the routing, and the slippage parameters to the entire network. When you broadcast your trade, it lands in the public mempool, where block builders analyze your exact bid. This transparency exposes you to MEV, or maximal extractable value. Specialized searchers identify your trade and insert their own orders around it to siphon off capital. Because of this transparency, users seeking privacy for large orders often move off-chain into centralized dark pools, which negates the primary goal of decentralized finance. Anoma addresses this by functioning as a protocol adapter and an intent machine, a layer designed to upgrade existing EVM capabilities natively, rather than competing as an isolated blockchain. This comparison table shows the execution baseline. On a standard EVM, the user maintains manual control but exposes data to a public mempool. Anoma shifts that control to solvers operating on an encrypted gossip network. This moves the network from an imperative architecture, where you dictate specific steps, to a declarative architecture, where you define only the final state you are willing to accept. An intent is a cryptographic message stating exactly what outcome you want and the constraints you accept, while omitting all routing instructions. By decoupling the desire for a trade from the mechanical execution, Anoma patches the transparency flaw and enables private multi-party coordination on a public ledger. On Uniswap, a user must specify the exact token route, gas price, and slippage tolerance for every transaction. On the left, an imperative transaction follows a rigid path, from your wallet to the public mempool, getting sequentially locked into a block. The Anoma intent lifecycle on the right is more fluid. Encrypted intents pass into a gossip network for matchmaking before reaching settlement. This matchmaking is handled by solvers. Solvers, like the entity Barter, are professional market actors that take on the burden of finding the optimal execution path for your intent. These solvers compete to fulfill your request, scanning on-chain liquidity pools and querying off-chain private inventory to satisfy your constraints. Solvers can also execute direct peer-to-peer ring trades. If multiple intents offset each other, they settle atomically, without needing an intermediate bridge token like Ethereum. Trading direct control for solver efficiency reduces gas and spread costs, shifting the balance of power from the block builder back to the user. To ensure solvers compete fairly, the network utilizes pre-execution privacy. Before an intent enters the gossip network, the user encrypts it using protocols like Fairblock. Fairblock uses MPC, or multi-party computation, a method where nodes process data without any single participant seeing the actual inputs. This turns the trade details into an opaque payload. The network can order and process these geometric blobs without reading the data inside. The network orders these blobs first, forcing solvers to commit to execution parameters blindly. The decryption key is only released and the trade details exposed after the order is finalized. This blind commitment neutralizes pre-execution MEV and allows for trustless, sealed bid confidential auctions on standard EVM chains. An intent is a set of constraints. These constraints can coordinate simple swaps or link together highly complex, conditional multi-party desires. The application Tetrix uses this to provide atomic hedging for liquidity providers. A user submits an intent to provide liquidity, bundled with a second intent to buy a put option. Both feed into the Anoma resource machine for atomic settlement. If the option cannot be sourced, the entire transaction instantly shatters, reverting to zero. Atomic bundling prevents leg risk, the danger of a trade filling while its hedge fails, effectively solving the impermanent loss problem. This logic allows builders to construct risk-managed institutional yield products that are structurally impossible to build on traditional transparent ledgers. Moving to the intent layer introduces a structural reliance on the efficiency and liquidity of the solver network. This decision tree shows when to use this infrastructure based on your goal, trade size, and privacy needs. For a simple retail swap of minor value, the overhead of intent routing is unnecessary. Stick with standard DEX aggregators. For large institutional trades, use the Anoma protocol adapter and solver networks like Barter to prevent market impact and MEV extraction. If you are a developer, target the resource machine to build advanced primitives like zero impermanent loss apps and private dark pools. Anoma functions as specialized infrastructure for high-stakes private economic coordination rather than a general replacement for everyday crypto transfers. We are moving toward a landscape where isolated, transparent ledgers are unified into a single, intent-driven operating system. The core innovation of Anoma is patching the EVM's lack of a double coincidence of wants. Separating human desire from computational execution moves the network past simple token transfers and toward digital barter, where complex trades settle natively at scale. Users no longer have to compromise on privacy or submit to MEV extraction to utilize decentralized rails. By removing the imperative transparency trap, Anoma elevates the EVM from a basic transaction ledger into a platform for global institutional-grade finance.